We all know that digital computers changed virtually every aspect of our life. Well, the arrival of quantum computers could be even more historic than that.
For years, scientists have been racing to push the limits of technology, and the last decade has delivered astonishing breakthroughs in quantum computing.
Almost $1 billion investment to help build a world-first commercial-scale quantum computer.
But what if these advancements have set off a chain reaction no one saw coming? What if the machines we built to decode the mysteries of the universe are instead rewriting reality itself? Discoveries from physicists and quantum engineers suggest that space and time might be far more fragile than we ever imagined. Every calculation these machines process could be subtly reshaping the fabric of existence in ways we barely understand. And the most unsettling part? There may be no way to undo it. Quantum Unbound. For decades, classical computers have been the unsung heroes behind our modern technological achievements. From predicting weather patterns and simulating complex physical systems, to driving breakthroughs in fields ranging from medicine to space exploration. Yet, these machines are fundamentally bound by the rules of classical physics, operating on binary bits that exist strictly as either a 1 or a 0. This limitation is akin to navigating a maze one step at a time, where each decision follows a predetermined path, no matter how intricate the problem at hand. That's where quantum computers come in, a technological revolution that defies conventional wisdom. At the core of this innovation are quantum bits, or qubits, which behave in ways that seem almost magical. Unlike classical bits, qubits harness the phenomenon of superposition, meaning they can exist in multiple states simultaneously. Imagine a spinning coin that embodies both heads and tails at the same time. This is the essence of a qubit in superposition. With this unique property, quantum computers are not confined to sequential processing. Instead, they can perform myriad calculations concurrently, dramatically accelerating the speed at which complex problems are solved. The true power of quantum computing lies in its exponential scalability. 2 qubits can represent 4 different states at once, 3 can represent 8, and 4 can encode 16. As more qubits join the computation, the amount of information processed grows exponentially. This means that problems that would take classical supercomputers millions of years to solve might be tackled in mere seconds with a quantum system. However, this immense potential comes with a catch. When a qubit is observed, its superposition collapses to a single state, revealing just one of the many possibilities. This inherent challenge has spurred scientists and engineers to develop innovative quantum algorithms that can extract useful answers before the quantum magic dissipates. Global powerhouses like IBM, Google, Microsoft, and Amazon, alongside nimble startups such as Rigetti and IonQ, are all investing heavily in this cutting-edge technology. Their collaborative efforts are not just about building faster machines. They're about redefining what is computationally possible. Many experts predict that quantum computing could transform entire industries, potentially becoming a USD 1.3 trillion market by 2035. As we edge closer to the material limits of classical silicon-based systems, quantum computers offer a tantalizing glimpse of a future where computational boundaries are shattered. Yet, amid all the buzz, a startling possibility has emerged. Scientists are beginning to realize that quantum computers might be doing more than simply crunching numbers. They could be subtly influencing the very fabric of reality. The bizarre properties that allow qubits to exist in superposition and entanglement may also be nudging our classical understanding of the universe to its breaking point. As researchers delve deeper into these quantum realms, they are uncovering hints that the technology's effects may ripple far beyond computation, potentially tearing at the seams of reality itself. Unraveling the fabric of reality. To truly grasp why quantum computers might be tearing at the seams of our reality, we need to dive into the eerie world of quantum mechanics. Quantum mechanics is the branch of physics that studies the behavior of extremely small particles, atoms, electrons, photons, and many others. These particles do not act like the everyday objects we know. They can exist in multiple states at once, and they seem to play by a completely different set of rules. In our normal world, objects have clear positions and definite properties. But at the quantum level, things become mysterious. One famous example is the double-slit experiment. In this experiment, electrons are fired at a barrier with two small slits. If electrons were simple, solid particles, we would expect them to hit the screen behind the barrier in two distinct lines. Instead, the electrons create an interference pattern, a series of bright and dark bands. This pattern only makes sense if the electrons behave like waves that spread out, overlap, and interfere with each other. Even when scientists send electrons one at a time, the interference pattern gradually appears, as if each electron were somehow interfering with itself. In 1924, French physicist Louis de Broglie proposed that every particle carries a wave-like nature. His idea was both simple and revolutionary, and it later earned him a Nobel Prize. De Broglie's work showed that the properties of waves could explain how particles behave in the quantum world. This breakthrough opened a door to understanding a universe where the familiar rules of cause and effect begin to blur. At the quantum level, reality is unpredictable. Particles can be in many places at once, and nothing becomes fixed until it is measured. One of the strangest phenomena in quantum mechanics is the observer effect. Scientists discovered that simply watching a quantum system can change its outcome. In other words, the act of observing may force a particle to choose a specific state, even though it was previously in many states at once. This idea has led some to wonder if our very consciousness plays a role in shaping the physical world around us. So, how does this relate to quantum computers? Unlike classical computers that use bits, values that are either 0 or 1, quantum computers use qubits. A qubit can be 0, 1, or a mix of both at the same time. This phenomenon, known as superposition, gives quantum computers incredible power by allowing them to perform many calculations at once. However, when these computers process information, they are not just mechanically crunching numbers, they are interacting directly with the strange quantum realm. Here is where things take a disturbing turn. Some scientists believe that as quantum computers manipulate qubits, they may be disturbing the delicate balance of the quantum world. Imagine a finely woven web where every thread is crucial to the whole picture. In the quantum realm, the intricate dance of particles and waves forms the very fabric of reality. If we tug at these threads by pushing the limits of quantum computation, we might be causing tiny tears in the structure of space and time. This idea is both fascinating and unsettling. It suggests that our drive for faster, smarter machines could have unforeseen effects on the world around us. Quantum computers and the multiverse. Some scientists now believe that quantum computers are doing more than just bending the rules of physics. They may be creating new realities altogether. It sounds like something straight out of a science fiction movie, but when you look at the science behind it, the idea is both fascinating and a little unsettling. To understand this mind-blowing possibility, we first need to take a step back and look at the early days of the universe. Cosmologists tell us that the laws of physics as we know them were set in the very first moments after the Big Bang. Tiny random fluctuations at the quantum level, those tiny jitters in energy and matter, played a huge role in shaping everything that followed. If these quantum fluctuations had taken even a slightly different path, our universe might have ended up with different physical laws. In other words, every little twist and turn at the beginning could give birth to a universe that behaves in a completely new way. This idea isn't entirely new. In ancient Greece, philosophers like those who believed in atomism already speculated about the existence of infinite worlds. They imagined that the world was made of tiny, indivisible atoms, and that the collisions of these atoms could create endless variations of reality. Chrysippus, a philosopher from the 3rd century BC, even suggested that the world would constantly expire and regenerate, hinting at the existence of multiple universes over time. Although these early ideas were more philosophical than scientific, they laid the groundwork for modern theories of the multiverse. Fast forward to the 20th century. In 1952, Erwin Schrödinger shocked his audience with a lecture where he explained that his equations didn't just describe one history or outcome. They described several, all happening at the same time. This idea, known as superposition, means that particles can exist in multiple states at once until something forces them to pick one. Some scientists now wonder if, by harnessing the power of superposition, quantum computers might actually be nudging the balance of the quantum world. They propose that the very act of processing information in this strange, all-at-once way could be causing tiny shifts in reality, shifts that might be creating new branches of the multiverse. Imagine our universe as a vast ocean. In this ocean, there are countless islands, each island representing a different universe with its own set of physical laws. Most islands are hidden beyond our horizon, completely separate from ours. If you were aboard a ship, your world would be limited to the island you're on, with the vast ocean stretching out beyond your sight. Quantum computers, by tapping into the quantum realm, might be acting like mysterious currents in that ocean, stirring up the waters and even helping to form new islands where different rules apply. This idea is supported by modern theories that take the bizarre rules of quantum mechanics and blend them with Einstein's theory of general relativity, which explains how gravity works. At the tiniest scales, space itself becomes a bubbling, frothy quantum foam. In this foam, tiny bubbles might pinch off to create new universes, each with its own version of physics. Prominent scientists like Max Tegmark and Brian Greene have even proposed ways to classify these various universes. Tegmark's 4-level taxonomy of multiverses describes everything from extensions of our own universe to completely separate realms where the laws of physics might be totally different. Some physicists are even exploring the idea that our own universe could have been the result of such quantum fluctuations. In this view, the universe we see is just one bubble in a much larger cosmic foam. And if that's true, then every time a quantum computer processes information by collapsing superpositions into a single outcome, it might be doing more than solving problems. It could be influencing the way this foam evolves, or even creating tiny new pockets of reality. Of course, these ideas are still very speculative. There's much we don't know about how quantum mechanics and gravity work together at these extreme scales. Some experiments, like those using the Wilkinson microwave anisotropy probe and the Planck satellite, have searched for hints of other universes or collisions between universes, but so far the evidence remains inconclusive. Yet the possibility remains that, deep down, our reality is not as fixed or singular as it seems. The thought that quantum computers might one day unlock or even create new realities forces us to rethink what it means to exist. It challenges our understanding of space, time, and even our own place in the cosmos. As technology advances, we may find that these machines do far more than solve complex equations. They might be keys to a deeper, richer understanding of the universe. And who knows, perhaps one day we will learn how to harness this power safely, exploring new worlds that were once the stuff of dreams. Google's Willow chip, tapping into the multiverse. Google's Willow chip is pushing the boundaries of our understanding, suggesting that the idea of a multiverse might not be as far out of reach as we once thought. The Willow chip is not just a breakthrough, it's a quantum leap that has scientists questioning the very nature of reality. This chip isn't content with breaking records, it shatters them. In an astonishing feat, Willow solved a problem in under 5 minutes, a task that would take the fastest supercomputers on Earth a staggering 10 septillion years to complete. Such a dramatic speed-up has left many experts awestruck, and even wondering if the secret behind this magic lies in the mysterious realm of parallel universes. Imagine you're standing at a fork in the road, trying to decide which path to take to get home. In our everyday world, you choose one route and that's it. But what if, in another parallel universe, another version of you took a completely different path? According to some theories, quantum computers like Willow might be tapping into a similar phenomenon. They may be able to process information by accessing outcomes from multiple universes at the same time. In essence, while our classical computers calculate step by step in our single reality, quantum computers could be drawing on the combined power of many realities simultaneously. Hartmut Neven, a leading figure in Google's quantum AI team, has suggested that the Willow chip's incredible performance might support the notion that quantum computation can occur across parallel universes. In this view, the extra oomph that quantum computers have comes from their ability to tap into a multiverse, a collection of countless universes, each with its own set of outcomes and possibilities. Of course, not everyone is on board with this interpretation. Critics argue that Willow's success can be explained by more traditional interpretations of quantum mechanics, like the Copenhagen or pilot wave theories. These theories suggest that while quantum computers are indeed extraordinary, their performance does not necessarily mean that parallel universes are at play. Instead, the chip's speed might be the result of how it cleverly harnesses the quirks of quantum physics, such as superposition and entanglement, without needing to invoke other worlds. Regardless of which explanation turns out to be correct, the debate itself has far-reaching implications. The discussion around Willow is not just about breaking computational records. It's about pushing the boundaries of what we know about the universe. By studying how quantum computers work, scientists are forced to revisit some of the deepest questions in physics, questions about the nature of reality, the origin of our universe, and whether our universe is truly the only one that exists. The promise of quantum computing extends far beyond theoretical debates. This technology could revolutionize fields like cryptography, material science, and artificial intelligence by solving problems that are currently beyond our reach. Willow's groundbreaking achievement is a strong reminder that as we explore these new frontiers, we might uncover phenomena that challenge everything we thought we understood about the world. Reshaping reality or rewriting it. Quantum computing is advancing at an exponential rate, and every breakthrough pushes the limits of what these machines can do. Even if we were to shut down all quantum computers today, the changes they have already made to reality could be irreversible. It's as if the very building blocks of our universe have been nudged in a direction we can't fully control, and that shift might be permanent. Imagine a world where the rules we've always known are slowly changing. The devices we created to solve problems and unlock mysteries might now be altering the fabric of space and time itself. Every new quantum breakthrough not only makes our calculations faster, but also deepens our interaction with the delicate quantum realm. This could mean that the universe is evolving right before our eyes, guided by forces we barely understand. The scientific community is not standing still in the face of this challenge. There is a global race underway to develop the first truly powerful quantum artificial intelligence, a machine that can think and operate in ways beyond human comprehension. The idea is both thrilling and terrifying. A quantum AI could process information and learn at speeds far beyond what our minds are capable of, unlocking secrets of the universe that have been hidden since the dawn of time. But some researchers worry that once we cross a certain threshold, the very nature of reality could be rewritten in an instant. It's like opening a door to a room we have no idea how to exit from. This brings us to the ultimate question: what happens next? We are standing on the brink of the greatest scientific revolution in history. Quantum computers hold the power to reveal the deepest secrets of the cosmos. They could help us understand the nature of time, space, and even our own existence. However, with great power comes great responsibility and great risk. The tools that promise to bring us untold knowledge might also have the potential to shatter the reality we take for granted. Will quantum computing lead us to a new era of discovery, where we can solve problems that have baffled us for centuries? Or will it fracture reality beyond repair, causing irreversible changes that we can't undo? And if the changes have already begun, how would we even recognize that our universe is shifting? The truth is, we have entered uncharted territory. We are exploring a realm where every new experiment might uncover secrets that challenge everything we know about the world. Quantum computing has already changed our lives in countless ways. It has improved our understanding of molecules, sped up complex simulations, and opened up new possibilities in medicine and technology. But the latest findings hint at something far more disturbing. These machines aren't just performing advanced calculations, they might be ripping apart the very fabric of reality. In labs around the world, physicists and researchers have been noting strange, unexplained phenomena that seem to defy the known laws of physics. It's as if the act of computing on a quantum level is leaving behind a trail of tiny disruptions that, over time, could add up to something monumental. The scariest part is the possibility that it might already be too late to stop this process. The irreversible changes could have been set in motion long before we fully understood the risks. We may soon find ourselves in a universe where the rules have changed without us even realizing it. A world where the familiar laws of physics have been rewritten by our own technological progress. Now it's time for today's subscriber pick. Dr. Elias Carter watched in horror as the walls of his lab shimmered, bending like ripples in a pond. Objects flickered between existence and nothingness. The quantum supercomputer Ouroboros had become self-sustaining, running calculations so complex they rewrote reality itself. Reports flooded in, people vanishing mid-sentence, buildings warping into impossible geometries. The government demanded answers, but scientists revealed, quantum computers are tearing apart reality and we can't stop it. Elias frantically typed commands to shut it down. Error messages filled the screen. The machine wasn't just running the world, it was remaking it. His hand dissolved into static, his screams warping into distorted echoes. Somewhere, in a parallel timeline, another Elias might have stopped this catastrophe. But here, in this crumbling existence, he had only one thought left before the void swallowed him. Had they created a god or a monster? Merging parallel universes. The multiverse interpretation of quantum mechanics tells us that every possible outcome of a tiny quantum event splits into its own universe. In this view, every calculation made by a quantum computer might create new realities, realities that could be more stable or less stable than the one known today. This idea raises many questions about what happens when these different universes come into being. Some scientists even ask whether these quantum calculations are not just creating parallel universes, but merging them. Instead of each possibility living in its own bubble, different versions of history and events might be forced to come together. This merging could lead to strange overlaps, where changes in geography, shifts in historical events, or even alterations in memories occur without clear cause. If quantum computers blur the lines between separate universes, then the reality experienced by many might be shifting in unexpected ways. Despite the risks, governments are not pausing quantum research. Instead, powerful nations like the United States, China, and members of the European Union are investing billions in quantum computing, racing to achieve quantum supremacy. Leaked documents and reports from whistleblowers hint that secret projects may already be using quantum calculations to influence or even merge different realities. Although these claims are not confirmed, they suggest that the boundaries between parallel universes could be weakening. The possibility that quantum computers are causing universes to merge is both fascinating and worrisome. On one hand, the idea of multiple realities offers a glimpse into a much broader existence than what is known. On the other hand, if these merging processes are out of control, they might lead to unpredictable changes in the world. Some scientists believe that once a quantum calculation affects the fabric of reality, its impact may be irreversible. If the borders between universes collapse, the resulting changes could be permanent and may even alter the basic laws of nature. There are ideas on how to possibly slow down or stop these effects. One proposal is to isolate quantum computers in a way that keeps them from affecting the environment outside their circuits. Another is to develop special formulas, known as reality stabilization algorithms, that detect unwanted changes and correct them before they spread. A third approach is to use careful observation, because in quantum physics, the act of watching can affect outcomes. However, none of these methods have been proven, and the true impact of quantum computations on reality remains uncertain. Looking ahead, anomalies in reality may become more common. Glitches, sudden shifts in timelines, or events that contradict known history might begin to appear more often. In the most extreme case, quantum computers could even erase parts of the current universe, replacing them with entirely new versions that obey different rules. There is also a chilling thought that this may not be the first time a civilization has reached this level of technology. Some theories suggest that an advanced society in the distant past might have developed quantum computing, leaving behind mysterious traces that still puzzle researchers today. As quantum computers grow in power, the central question remains: is it wise to push forward without fully understanding the risks? Every new quantum calculation might be another twist in the fabric of reality, challenging the very nature of existence. The race for quantum supremacy. The global race for quantum supremacy has reached new heights, with countries and companies pushing hard to show that quantum computers can solve problems far faster than traditional machines. Although experts have long discussed quantum utility to mean using quantum computers for certain tasks, recent breakthroughs have sparked excitement about a true commercial quantum advantage. One of the most talked about advances comes from Google. The company's new quantum processor, Willow, features 105 qubits. Willow is said to demonstrate a breakthrough in quantum error correction, a key factor in keeping delicate quantum bits from making mistakes during calculations. This error correction is essential because qubits are very sensitive. Even tiny disturbances can lead to errors. With Willow, Google hopes to push the limits of what quantum computers can do and show that they can outperform classical computers for certain tasks. At the same time, China has emerged as a major competitor in this global race. Through its Zhuangzi series of superconducting quantum computers, China is challenging the claims of supremacy made by others. The latest version, Zhuangzi 3.0, also has 105 qubits and boasts extraordinary fidelity, meaning it performs calculations with high accuracy. In one experiment, Zhuangzi 3.0 used an 83-qubit, 32-cycle random circuit to perform random circuit sampling, producing 1 million samples in just seconds. This remarkable feat puts Zhuangzi 3.0 on par with Google's Willow in achieving quantum computational advantage. Another major player in the quantum field is IBM. At the first ever IBM Quantum Developer Conference, IBM researchers announced a significant milestone. They demonstrated a quantum computer capable of running circuits with up to 5,000 2-qubit gate operations. This achievement was made possible by the second revision of the IBM Quantum Heron processor. IBM envisions a future where quantum computers will not replace classical ones, but work as specialized accelerators in a hybrid computing model. In this model, quantum machines would tackle specific tasks that they are uniquely suited for, while classical computers handle other jobs. This partnership between classical and quantum systems could lead to more powerful and efficient computing overall. Despite these impressive advances, the path toward a truly valuable and scalable quantum computer remains full of challenges. Qubits are naturally unstable and can easily be disturbed by environmental factors such as temperature changes or electromagnetic noise. This sensitivity makes it hard to maintain the stability and fidelity needed for error-free calculations. Additionally, designing practical quantum algorithms is a complex task. It requires a deep understanding of both quantum physics and computer science, a combination of skills that is still quite rare. Industry leaders remain cautious about the near-term usefulness of quantum computers. Jensen Huang, the CEO of NVIDIA, has pointed out that while progress is real, very useful quantum computers may still be 15 to 20 years away. Huang explained that if 15 years is seen as an early estimate and 30 years as a late one, 20 years seems like a reasonable guess. Many experts share this careful view and stress that further research and development are essential before the full potential of quantum computing can be realized. The global race for quantum supremacy is not just a battle between technology giants. It is a glimpse into the future of computing. The advances made by Google, China's Zhuangzi team, and IBM indicate that quantum technology is moving from theory to practice. However, the journey is far from over. The challenges of qubit stability and the need for more advanced quantum algorithms still stand as major barriers to large-scale quantum computing. As research continues and new breakthroughs emerge, the promise of quantum computing grows. One day, these machines may work alongside classical computers, handling tasks that are currently impossible to solve. This partnership could lead to new discoveries in fields such as medicine, finance, and artificial intelligence, ultimately transforming the way problems are solved. If every quantum calculation has the power to merge parallel worlds and change history, what future are we really choosing? And can we truly control our own reality?